Hello everyone, welcome to IIT Foundation classes. This is Srinivas, your maths faculty. So let us move on to the today's class. Today we are going to deal with the topic of LCM and HCF, right? So LCM and HCF, least common multiples. Before that, we should discuss about the concepts of what are called multiples and what are called factors. Okay. Now let me discuss with what is multiple and what is factor. For example, if you take a table like 7 threes are 21. 7 threes are 21. Here 7 and 3, the both of the number are factors of 21. 7 and 3 are factors of 21 and 21 is the multiple of 7 and 3. 21 is the multiple of both 7 and 3 and both 7 and 3 are the factors of 21. Simply when two numbers are multiply each other, each of the number is called factor to the product. Each of the number is called factor to the product, right? Now same way, the product will be there. When you get the product, the both of the numbers are the product will be the multiple of both of the numbers. Okay, so very simple logic here. For example, here for doing that LCM is nothing but least common multiple. LCM means least common multiple, right? So there are multiple ways to find out the LCM of any two numbers or more than two numbers. For example, we can just identify their multiples. We have to find out the multiples of each and every number. Then we have to find out the least among them. So that is the one of the method. So directly writing multiples, we can find out the least common multiple, LCM. Or else we can use the prime factorization method also. We can use prime factorization method, or we can write all its multiples and we can identify what is LCM, or else we can use the continued division method or common division method we can use for identification or to find out a LCM of two numbers or more than two numbers. For example, I'm taking the numbers like 5 and 15. So the different methods while you're observing, first of all, I can write all the multiples of 5. That means what are the numbers will come in 5 table, we need to write it. So like 5 2s are 10, 5 3s are 15, 5 4s 20, 25, 5 6 are 30 and so on. These are all multiples of 5. Okay. Same way, multiples of 15. So 15 1s are 15, 15 2s 30, 15 3s 45, 15 4s 60 and so on. So I have written all the multiples of 5 and all the multiples of 15. That means there are so infinite number of multiples will be having for each and every number. That is different matter. So I am just trying to write the multiples of first number and multiples of second number. Now try to identify the common multiple among both of them. See, 5 is not here available. 15 is a least common multiple. 15, 30, 45, like common multiples will get. Among them, least one is nothing but 15. So LCM is nothing but least common multiple. So I have identified the common multiple among them. So among them, the least will be the LCM of 5 and 15, which is nothing but 15 itself. Okay. I know that you are all having awareness about that what are prime numbers and what are composite numbers, right? Yeah. Now, when you take any two prime numbers, let me discuss about what is prime number. So, prime number, which is nothing but a number having exactly two factors. A number is having exactly two factors are called prime numbers. And what is prime numbers? A number having exactly two factors. What are the two factors? 1 and itself. Such type of numbers are called prime numbers. So simply we can write that a number having exactly 2 factors. Okay, such type of numbers are called prime numbers. Okay, so example like 2 is a prime number. So what are the factors of 2? 2 factors are nothing but 1 and 2. 1 and itself, only 2 factors. So 2, 3, 5, these are all numbers having only 2 factors. Such type of numbers are called prime numbers. Again, there are some types of prime numbers are there, nothing but co-primes or relatively primes. What do we call? Co-primes or relatively primes. Co-primes or relatively prime numbers, which means you can take any 2 numbers in the set of natural numbers. When you take any 2 numbers from the set of natural numbers, the common factor between the numbers, is only 1. Such type of numbers are called co-primes or relatively prime numbers. So simply, there is no common factor between 2 numbers. Such type of numbers are called relatively primes or co-primes. No common factor means only 1, except 1. Except 1 means 1 is the factor of every number, because every number will come in one table, right? So that we have to decide that 1 is a common factor for every number. So except 1, there is no other factor between 2 numbers. Such type of numbers are called co-primes. Okay. For example, 2 and 3. 2 and 3 having only 1 is the common factor. There is no other common factors between them. I am talking about factors, not multiples. Okay. Right. So only 1 is a common factor between 2 and 3. Then we can say that 2 and 3 are called prime numbers. Or else we can say in another way also. Co-primes or relatively primes are nothing but HCF of 2 numbers becomes 1. We can say in different manner also co-primes, that is HCF of any 2 numbers. HCF of any 2 numbers is 1. Then we can say that the 2 numbers are called co-primes or relatively prime numbers. For example, if you take any consecutive numbers, example, any 2 consecutive numbers. Consecutive is nothing but side by side numbers. If you take any 2 consecutive numbers, they are always prime numbers, co-primes. They are always co-primes. For example, 31 and 32. 31 and 32, there is no common factor between them except 1. So that we can say that 31 and 32 are called co-primes or relatively prime numbers. Okay? Right. So this is about a co-primes. And also one more prime. Set of primes are there, nothing but twin primes. Twin primes are nothing but you have to take only prime numbers and their difference is 2. Such type of numbers are called twin primes. What is called twin primes? You are having only prime numbers you should take, and the difference between the prime numbers is 2. Such type of primes are called twin primes. So simply we can write difference between primes, difference between prime numbers or primes is 2. Such type of primes are called twin primes. So there we can take an example like 3, 5. 3 and 5 both are prime numbers, and their difference is nothing but larger number minus smaller number. Okay. Same way 5 and 7. 5 and 7 both are prime numbers and their difference also 2. So that we can decide these 2 are called twin primes. 3 and 5 are twin primes and 5 and 7 also twin primes. Same like that 11, 13. 11 is a prime number, 13 is a prime number, and the difference between them is 2. So that we can say that 11 and 13 are called primes. Which primes? Twin primes. Okay. So till then we have discussed about what is multiple and what is factor. Then prime numbers, co-primes or relatively prime numbers, and twin primes. Okay. These are the concepts we have discussed. And what is HCF? HCF means we have discussed about the factor, right? Factor means what? When 2 numbers are multiply each other, each of the number is factored to the product. For example, I have taken that 7 into 3. 7 3 is 21, where 7 and 3 are called factors of 21. Okay. So like that, we have to identify all the factors of two numbers. There are three different methods. First one, we need to write all the factors, and among them, highest one we need to find out. Highest common factor between two numbers will be the HCF. Same way, we can use the prime factorization method or continued division method. So total three different methods we are using to find out the HCF of any two numbers or more than two numbers. Clear? Right. Yeah. So this is about HCF. So let us go through the first question here. Let us see the first question here. HCF of two co-prime numbers. I told you the definition of co-primes. Any two consecutive numbers. If you take the two consecutive numbers, always becomes co-primes. The definition I have given that there is no common factor between any two numbers except one. Such type of numbers are called co-primes or relative primes. Or HCF of any two numbers is 1. HCF of any two numbers is 1. Such type of numbers are called co-primes or relatively prime numbers. So according to the question, HCF of two prime numbers will be 1, then the two primes are called co-primes or relatively prime numbers. Clear? Right. So let us move on to the next problem. So HCF of consecutive even numbers. So take any two consecutive even numbers. Consecutive means side by side even numbers. For example, 30 is an even number. So its immediate next even number will be 32. 30 and 32 are called consecutive even numbers. Or 500, 502 both are called consecutive even numbers. Same way, 1 and 3 both are consecutive odd numbers. Or 31 and 33 consecutive odd numbers. 5 and 7 consecutive odd numbers. Clear? Consecutive means side by side or immediately next. Now here, consecutive even numbers. So for example, I am taking two even numbers like 34 and 36. I am taking my own examples. 34 and 36 both are even numbers and both are consecutive. Both are consecutive. That means 34 after immediately 35 will come. 35 is odd number, but we have to take next number 36 is even number. Therefore 34 and 36 are consecutive even numbers. Now try to find out the HCF. I am using the continued division method. How to do HCF in continued division method? The smaller number always taken as divisor and the larger number is always taken as dividend. Okay? Divisor is always in here and dividend is in the middle part. Next, 34 and 36. 34 table here, 34 ones are 34. After subtraction, we will get the remainder 2. Then we have to continue this division until you get the remainder 0. Now this remainder becomes dividend and the divisor becomes dividend. Remainder becomes divisor and divisor becomes dividend. So 2 table 34 is 17 times. So we got the remainder 0. When you get the remainder 0, its divisor will be HCF. Okay, na? HCF of two consecutive even numbers. Or any two consecutive even numbers is always 2. Okay. So this is the method we have. We can call it as continued division method, or we can use prime factorization method also, or else we have to find all the factors of 34, all the factors of 36, among them highest common factor we need to find out. Okay, right. So this is the second question and the answer is option 1, even number. Okay, na? So let us move on to the next problem. Right, now see here, HCF of two consecutive even numbers. Same question is repeated. HCF of consecutive even number. HCF of consecutive even number and odd number. So this question solution is for third question. Sorry for reading the wrong question here. The consecutive even number and odd number. consecutive even number and odd number. That means, for example, if I take that 32 is a even number, its consecutive odd number is nothing but immediately next number. 32 and 33. As we discussed as a definition of co-primes or relatively prime numbers, we have concluded that if you take any two consecutive numbers means one even number and one odd number. Our number system is designed like, while you are observing the number system or set of natural numbers. So first it starts with 1. 1 is nothing but odd number, next even, odd, even, odd, even. It is following one pattern, right? That means the number system, all the numbers are arranged in a manner like odd number, even number, odd number and even number. So that if you take any two consecutive numbers, that means if you take 31, its immediately next number is 32, odd and even. And if you take any two consecutive numbers, the HCF is always 1. HCF is always 1. Okay. So let us see this, how the HCF of any two consecutive numbers always becomes 1. Let us discuss with the example. Same 32, 33 numbers I have taken by one examples here. Okay. Yeah. So 32 and 33. I told you always the smaller one as divisor than the larger number is taken as dividend. Okay. So 32 table, 32 ones are 32. Remainder is 1. And the next step, divisor becomes dividend. And 1 table 32, 1 32s are 32. Remainder 0. So when you get the remainder 0, its divisor will be HCF. So that you have to conclude that HCF of any two consecutive numbers is 1, and they are also called as co-primes or relatively prime numbers. Clear? Yeah. So let us try to move on to the next question. Right. Just now I have concluded this HCF of two consecutive even numbers. So take any two consecutive even numbers. So 32 and 34. Consecutive means immediately next numbers, means side by side numbers. So 32, 34, HCF is nothing but highest common factor. So we can identify HCF by doing continued division method, prime factor method, or writing all its factors also. Okay. Now 32 here, 32 ones are 32, remainder is 2, and the divisor becomes dividend. 2 table 32 16 times. 2 16s are 32, remainder 0. So when you get the remainder 0, its divisor will be HCF. Okay na? So when you take any two consecutive even numbers, the HCF is 2. Okay. And when you try to find out the HCF of any two consecutive numbers, I am not mentioning about any two even or any two odd. I am just mentioning about the consecutive numbers. Consecutive numbers HCF is always 1, and we can call them as co-primes. Okay. Right. So let us move on to the next problem. See, what is the greatest number which divides 10 and 30? Greatest number which divides 10 and 30, which is nothing but its HCF. The greatest number which divides 10 and 30. What is the meaning of the greatest number which divides 10 and 30? That means there is a number, that number should be divide 10 and divide 30. That means in that number 10 should come, 30 should come, both of them should come. That means which is nothing but clearly their HCF. The greatest number which divides 10 and 30 is their HCF. HCF which is nothing but highest common factor. Now I am doing the prime factorization method here. Prime factorization means I can take prime factors of the numbers separately. Okay. Now first 2 table I am taking. So 2 table in 10, 5 times 2 5s are 10. 5 is already a prime number 1. So 10 we can write it as 2 into 5. 10 we can write it as 2 into 5. Now 30. 3 table, 3 tens are 30, 2 5s are 10, 5 ones are 5. So 30 we can write it as, so which are nothing but factors of 10, prime factors of 10, prime factors of 30. Okay, na? Prime factors of 10 and prime factors of 30. 30 factors are nothing but 2 into 5 into 3. 2 into 5 into 3. Now identify the common terms. So we can find the common term is 2 and the common term is 5. So 2 into 5, which is nothing but 10. So 10 is the greatest number which divides 10 and 30. Okay, na? So nothing but simply their HCF. Clear, children? So let us try to move on to the next problem. Right, GCD. GCD, which is nothing but another name of HCF, highest common factor. Here GCD means greatest common divisor. Highest common factor, greatest common divisor. Factor and divisor both are same here. Okay, so we can call it as HCF or GCD. Anything is same. Highest common factor of 4 and 12. 4 and 12. So directly we can do it. So smaller number always in the left side and the larger number as dividend. Smaller number is always as divisor, largest number always as dividend. Now 4 table 13, yes, will come 4 3s 12. So when you get the remainder 0, its HCF is nothing but the divisor. So divisor here is 4, therefore HCF of 4 and 12, which is nothing but 4. Okay, right. So let us move on to the next problem. The GCD of 4, 8 and 16. GCD, which is nothing but greatest common divisor, we can also call it as highest common factor. So what are the numbers are given here? 4, 8 and 16. There are 3 numbers. We need to identify the common factor among them. So I can use the prime factorization method or continued division method. So for me, prime factorization method feels easy. So I am taking 4 and try to find out its prime factors. So 2 table 4, 2 2s are 4, 2 1s are 2. So 4 I can write 2 into 2. Next 8. 8 also. So 2 table 2 4s are 8, 2 2s are 4 and 2 1s are 2. So 8 we can write it as 2 into 2 into 2. Now coming to 16 prime factorization. 2 8s are 16, 2 4s are 8, 2 2s are 4, 2 1s are 2. So 16 we can write it as 2 into 2 into 2 into 2. Okay. GCD or HCF. GCD equals to, identify the common factors. 2 is in everywhere. So 2 we can write. Here one more 2 also there. So 2 into 2, which is nothing but 4. So HCF of these 3 numbers is 4. Okay. Yeah, please look into it. So we can go to the next problem. The prime factors of 24. Prime factors of 24. 24. Try to identify the prime factors of 24. First 2 table. 2 12s are 24. Again 2 table. 2 6s are 12. 2 3s are 6. And 3 1s are 3. So 24 we can write it as 2 into 2 into 2 into 3. But what is the question which is asked here? Prime factors. Prime factors means 2 is a prime factor. These two also same number. These three are all of 3 are same numbers. We can write only 1. So 2 is a prime number. Here 3 also a prime number. So 2 1 3. So prime factors equals to 2 and 3. Okay. So option number 2 is our correct answer. So let us move on to the next problem. Yeah, the LCM of two prime numbers A and B. LCM of two prime numbers. Yeah, coming to the point here. So HCF of prime numbers or HCF of co-primes or HCF of any two consecutive numbers we have discussed. HCF of co-primes or HCF of any two consecutive numbers is always 1. Same way HCF of two prime numbers also 1. If you take any two prime numbers, for example 7 and 11 are two prime numbers. 7 and 11 are two prime numbers. Then identify the HCF of both of them. HCF means what? Highest common factor. Highest common factor. When you're taking the factors of 7, 7 is a prime number. 7 factors are 1 and 7. Same way 11 factors 1 and 11. So 7 we can write it as 1 into 7. 11 we can write it as 1 into 11. Any common factors only 1. Except 1 there is no common factor among them. Therefore HCF of any two prime numbers is always 1. HCF of any two prime numbers is always 1. And same way LCM of any two prime numbers. For example, LCM means what? LCM are nothing but least common multiples. Least common multiples. For example, if you take the prime numbers like 7 and 11, 7 multiples 7, 14, 28, like that we can take. Okay, na? Or 7, if you wanted to write 7 as a prime factors like 1 into 7. Yeah, 1 second. Here LCM, no? LCM of any two prime numbers is always their product. Let us see. For example, 7 and 11. Okay, na? 7 and 11. LCM of both of them. There is no such table which comes both 7 and 11 table because both are prime numbers. There is no common factor to check the table. Only one is a common factor. So if you wanted to find that division method like 7 ones are 7. So 7 table 11 won't come. 11 as it is 11. And again 11 table 1 won't come. 1 as it is 1. 11 table 11 one time. So therefore LCM, which is nothing but 7 into 11, that is equals to 77. So clearly how to decide that prime factors or LCM of any two prime numbers is always their product. I am writing here LCM of any two primes is always their product. Now here clearly given that A and B are prime numbers. A and B are prime numbers. Then their LCM is their product. Product means A into B, AB. Okay. So let us move on to the next problem. Right. LCM of 4 and 12. Now I am using the common division method. 4 and 12 together I am taking. So any common table between 4 and 12, yes, 2 table will come. 2 2s are 4 and 2 6s are 12. Again 2 and 6 have a common table which is nothing but 2. 2 table 2 1s are, 2 3s are, and there is no common factor between 1 and 3. Okay. Oh. Okay. So LCM, we can write it as LCM equals to 2 into 1 and 3, there is no common factors or there is no table which comes 1 and 3 together. So 1 as it is 1 and 3 as it is 3. So 2 into 2, 4, 4 3 is 12. 12 is the LCM of both 4 and 12. Okay. Or else you can take continue here. So 1 table and 3 table you can take 3. 3 table 1 won't come as it is, 3 table 3 one time. So 2 into 3. 2 2s are 4, 4 3s are 12. Therefore LCM of 4 and 12 which is nothing but 12. Okay, please look into it. Right. So let us move on to the next problem. Problem number 10. The LCM of 8, 12 and 18. 8, 12, 18. LCM. Least common multiple continue method or division method I am taking here. So 8, 12, 18 all are multiples of 2. So I can take 2 table. 2 4s are 8. 2 6 are 12 and 2 nines. Okay, again 6 and 9 both will come in 3 table, and 4 and 6 both are coming in 2 table. So I can take 2 table here. 2 2s are 4, 2 3s are, and 2 table 9 won't come, 9 as it is 9. Now again 2 table 1 will come. So 3 and 9 won't come in 2 table, right, as it is 3 and 9. Now 3 table. 3 table 1 won't come as it is 1. 3 ones are, 3 threes are. Again 3 table 1 1 1. Therefore LCM equals to 2 into 2 into 2 into 3 into 3. So 2 2s are 4, 4 2s are 8, 8 9s are 72. 8 9s are 72. Okay? Yeah. So let us move on to the next problem. Multiple choice questions are given here. Now when you take x value, x equals to 2 into 2 into 3 into 3 into 5. This is the value of x. That means the number x is already factorized, prime factorized, and it is given its prime factorization. And y is the second number, and its prime factorization is given like 2 into 3 into 3 into 3. And we need to identify the LCM. So this is called prime factorization method. LCM of x and y. So let us try to identify the common numbers here. So 2 is a common number. Yeah, 3 and 3. 2 into 3 into 3. And any other common numbers will be there in its prime factorization. There is no common number is involving here. So you can write the remaining numbers. That means 2 we have to write, 5 we have to write, 3 also we have to write. So I am using in different color, like 2 into 5 into 3. These are the remaining numbers. Then what is the LCM? LCM means we need to multiply all the numbers here. So 3 3 is 9, 9 3 is 27, 27 2s are 54, 54 and 5 2s are 10. 54 into 10, which is nothing but 540. Therefore LCM of x and y, which is nothing but 540. Okay, so let us move on to the next problem, children. Yeah, numerical type of questions. So which is given that the HCF of two numbers p and q such that p, which is in the format of 3 into 3 into 17. Okay, and also into 18. So 3 into 3 into 17 into 19, and the q is one more number which is having 3 into 19 into 6. So to identify the LCM and HCF, so try to check their prime factors. That means all the factors are being in primes or not. Just try to check, or else you need to convert them into prime numbers. Okay. So for P, 3, 3, 17 and 19 all are prime numbers only. So I can write as this 3 into 3 into 17 into 19. All are same prime numbers. But Q values, 6 is not a prime number. So I am writing 6 as 3 into 2. Okay. Now what we have to find, actually we need to find the HCF. HCF, which is nothing but we need to check only the common factors among these two numbers. Yeah, I am just trying to circle the common factors here. So 3 is the first common factor, so I can write here. Yeah, 19 also the common factor among this. 3 into 19. And any common factors? Yes. One more 3 is there. And what are the remaining numbers? 17 and 2. Both are different primes, so we cannot take it as a common factors. So we are having only the common factors are nothing but 3 into 3 into 19. So 3 3s are 19, 19 into 9. 19 into 9, which is nothing but 171. Therefore HCF of both of the numbers is 171. Okay. So let us move on to the next problem. Right, LCM is given. So LCM of 18 and 27. So we can find by using the prime factor method or common division method also we can use. Yeah, I am using here prime factor method. So first try to find out the prime factors for 18. So 18, 2 tables, so 2 9s are 18. Again 3 table I am taking, 3 3s are 9 and 3 1s are 3. So 18 I can write as 2 into 3 into 3. The prime factorization of 18, which is nothing but 2 into 3 into 3. Now second 27. First prime number 2 won't come in 27. Let us take 3 table. So 3 table 27 9 times. Again 3 table 3 times and 3 table 1 time. So 27, which is equals to 3 into 3 into 3. What we have to find? LCM. LCM means common multiples, right? So what are the common numbers here? Common numbers are 3, here 3. So among these twos, 1 3 you can write. Here among these two threes, 1 3 you can write. And what are the remaining 2 1 3? So for HCF we are taking only common factors, but here LCM common factors along with remaining numbers also. Okay na? So I have taken the common factors 3 and 3, and the remaining numbers are from the first number 2 remains and from the second number 3 remains. I have taken all of them. Now the LCM equals to 3 into 3 9 and 2 into 3 is 6. So 9 6 are nothing but 54. Therefore LCM of 18 and 27, which is equals to 54. That means 18 table 3 times 54, 27 table 2 times 54. So least common multiple. Okay. Sorry. Let us see the last question, children. Yeah. The 14th one, which is given that the number that should be subtracted from HCF of 510 and 270. First of all, let us find out the HCF of these two numbers. Then, what is the number should be subtracted from HCF to get 24? Okay, so I am finding the HCF by using the prime factor method. So the two numbers are nothing but 510 and 270. So to find HCF of these two numbers, I am using the prime factorization method. Okay, so try to find out the prime factors for 510 and 270. So 510 I am taking the 2 table here, 2 2s are, 2 5s are and 2 5s are. So nearly 255 times. So again 5 table, 5 5s are 25 and 5 1s are 5. Now 3 table, 3 1s are, 3 7s are, 17 times nothing but. So 17 is a prime number, 17 1s are 17. Okay. Now here 2 table, 2 1s are, 2 3s are 6, 2 5s are 10. So 2 table 135 times. Now 5 table 5 2s are and 5 7s are. Now 3 table in 27 9 times. 3 table in 9 3 times and 3 table 1 time. So I am writing all its prime factors. So 510, I am writing the prime factors in ascending order. So 2 into 3 into 5 into 17. Okay. And 270, which is 2 into 3 into 3 into 3 into 5. So HCF means only common factors. We need to find only common factors. 2 is the first common factor, and here 3 also the one of the common factor being here, and 5 also one of the common factor. So 2 into 3 into 5. 2 3s are 6, 6 5s are 30. Now according to the question, what number should be subtracted from HCF? HCF we got 30. What number we have to subtract from 30 to get 24? So which is nothing but the required answer is 30 minus 6, which is equals to 24. Therefore required answer must be 6. How much we have to subtract? We have to subtract 6. 6 must be subtracted from HCF to become 24. Okay, so that's it for today, children. Thank you one and all. Have a nice day. Bye bye.